Hello everyone. So today I'm gonna do another custom request from one of the patrons. So today I'm gonna show you how to rotate the head as I move the mouse like this. So if I look at this way, if I move the mouse up, I move mouse forward, the character look up. And if I move the mouse backward, character looks down. Similarly to the left and to the right. So yeah, that's the part I'm going to do today. It works also in like this as well. Okay, so yeah, and this person has already attempted to implement the head rotation, and this is how it works so far. It's not perfect, but it works up to some extent, and this is how he has done it. Here he has defined three transform modify pawn nodes in the animation blueprint. One is for neck, and one is for head, and one is for chest. So for the neck he has used alpha 0.5, and for the head alpha 0.25, and for the chest also alpha 0.25. If I show you the skeleton, it is like this, and the neck one is here, and chest is here, and head is here. So then using this head rotator variable, and he directly update this head rotator variable from the third person character blueprint using this custom event, which he has called in the tick like this, and then casted it to this escort animation blueprint. I don't like this casting approach very much because as it creates a concrete reference to the animation with the animation blueprint, but this is the way he has done it. So right, and he has defined it using this camera manager and blah 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 like this. So okay, anyway, let's keep the same structure, and let's write this part fresh. Right, to help us with the calculation, so let's add uh, some object, let's say cube. It should be very small. This is to assist us with the calculations. I'll place it like this. So what I'm trying to do is I'm gonna make this character look at this cube, keep his head rotated towards the cube. Let's make it child of this mesh. Okay, alright, now oh wait a minute, let's add another scene component as the pivot. So this should be a child of this mesh, and this cube should be a child of this, let's call it head pivot, right? I'm not going to attach it to any of the sockets because if I do that there will be problems as with the animations. So right, I'm gonna disable the collisions for this because I don't need any collisions here. This is just to assist us with the calculations. Right, now let's go here and oh, wait a minute, this head pivot should be in the head actually, so no rotation, maybe like this. Okay, and the cube should be in front of it like this, no rotations. Okay, now here let's call this case target, and then let's get this and find look at rotation. Wait, let's put this code aside for now and take only this part. Let me collapse this. I only need this part. Let's leave this part. Oh wait, this is bad because I call this head rotation in the tick, so that means in the tick I do this casting always, which is really bad. So therefore let's go here, let's define an interface. We don't have any interfaces, right? No problem. Let's create a blueprint folder pp, and let's create a blueprint interface ppi code, no, ppi animation set head rotation, and we need a rotator here. Then let's add implement that interface here, PPI character animation, and when I implement that I get this set head rotation. Okay, now let's go to event graph and call set head rotation event, So all I have to do is set this variable like this. Okay, so now we don't need this part. Get animation is get animation set head rotation. So how do we calculate this? Using this gaze target. If I move this up, right here, now that we have disconnected, we can see the head is straight, right? Even if I move the mouse, head doesn't really rotate. So let's see how this behaves if I manually set this head rotator. Just for testing, instead of doing any kind of a calculation, let's try feeding a value like this 90 just to see what happens. Take here. Okay, 90 means he's directly looking down. Alright, so that means if I set minus 90, it should be looking up. Yeah, cool. So what about, oh wait, is it same even if I rotate the character? Yeah. Okay, that's funny. Let's make it 0 and let's change this one. Okay, plus 90 means look at right in the job, minus 90 means look at left. Okay. Oh, sorry, I have left the mic on the table, so that's why it was a little noisy. Right. Okay, now mic is in the proper place. Alright. And now that I think about it, I wouldn't even need this thing I set up to help with the calculations. So yeah, so we can do something like this. We can set this head rotator value this way. Let me split this. And so based on the vertical movement of the mouse, actually vertical means move forward and backward of the mouse, so that means what's the input again? Input axis for not move forward, look up. Yeah, look up and look right. Where is the head rotation? Yeah, here. Here I can get the look up axis value like this, and then I can also get the head rotator, the current value like this. So I need to change this role. We can look this value using this lookup as alpha. B is 90, and let's clamp this. Oh wait, clamp this between plus 90. No, let's limit it to 60. Plus 60 and minus 60 and plus 60. And to reduce the speed, let's multiply this with delta seconds, get world delta seconds. Right, let's see what happens. Okay, now when I move the mouse up and down, the character looks up and down. Okay, so right, and oh, I forgot to check what happens when I move in. Okay, it works without any issue, and despite of the rotation of the character. Now let me delete this too. I don't need it, sorry about that. Okay, and another requirement of the pattern is like, if I'm not moving the mouse, after a while it should return to the regular head direction. That means look straight forward. So we can do it like this. We can select this B based on the lookup value. If the lookup value is equal to 0, it should be 0, otherwise 90. Now let's see, as I move up, oh, it doesn't return. Let's print this value so we can get an idea. It's 0 and 0, but it's not returning. Right. Actually, oh, it doesn't matter what I change here. When this is 0, alpha becomes 0, so it doesn't change. So this part doesn't really work. So leave this as 90, and then we can select this. Using this value, if this is not 0, we have to use the regular path. Otherwise we can club this value with 0 with let's say, what should be the alpha? Shall we connect this? Let's connect it with the multiplier. For now I'll leave multiplier as 1. Oh, it doesn't change at all now. What's wrong? Sorry. This should go to A. And oh no. Yes. This should go to A and this should go to B. Because if lookup is 0, that means I should return to normal position, otherwise I should look up or down based on the direction I am moving the mouse. Right. So if I move up, yeah, it works now. Yeah, it returns. So maybe we can slow down this a little bit, so it would be better. Yeah, maybe 0.1. Let's see. It doesn't look very natural though. Oh, what can we do here? Okay, we can refine it later. For now, let's use something like 0.3. Right, that's better. Now look how to make it look left or right. So similar to this, we have to use the input look right. Let me put a comment here. I can't find it. Okay. I don't need this print now. For this one either. So I'll collapse this as now. Let's add a comment. Up, down. Similar to this. Let me duplicate it. Now I'll connect yo and now instead of roll I should use yo, like this, and instead of look up look right. Now there will be a problem when the character look at the camera and when the character look away from the camera, there will be a problem change in the direction. So it works alright when the character is looking away from the camera. As I move mouse left, character look to the left. As I move right, character look to the right, like this. But if the character is looking at the camera, let's see. Now if I move the mouse left, character look right. If I move the mouse right, character look at left. So how to fix that? Well, here we can, so all we have to do is multiply this alpha with the -1 if the character is facing the camera. But how do we know if the character is facing the camera? So actually we can test it like this. We can use this theory. Dot product of two vectors, it is the result is positive if the both the angle between vectors are smaller than 90 degrees. Otherwise it is negative. So I think we can use this theory here. So the camera, and since we have a follow camera system, spline based camera system, I'm not sure if this is the one that we always have. So therefore, okay, we can access the camera, play a camera manager like this, and get forward vector from the transform component. And also we can get forward vector, get actor forward vector, and get the dot product between these two vectors. Now if this one is larger than 0, that means the camera and the actor is facing the same direction. Otherwise it is facing at each other. So we can select this multiplier like this. If this is true, a should be 1, otherwise -1. Let's see if this theory works. So far alright, up and down, okay, everything is okay. Okay, it's working. So when I move the mouse left, it look at his right but left to the screen. If I move the mouse right, it looks at his left, that means the right in the mouse. Now it is alright. Cool. Right, also I have one more requirement. I want to see, like, as I move the, no, that's okay. Right, so I'm gonna stop this episode at this point, and yeah, so okay, that's it for today. So if you would like to support my work, you can get the membership of the Patreon club. Link would be in the description below. And thanks for watching. So see you in the next episode. Goodbye.